Right, next we're going to talk about the change of variables. Um, okay, the symbol K is used to represent the index of summation. It can be changed into some other symbols. We do not necessarily have to use K all the time without changing the effect. Okay, so this should be quite obvious to you. Uh, so, for example, we have two summations. Okay, in this case, my index is K. So everything is in the formula is expressed in terms of K in order for it to work. So you have K equals to 1 to 4. Formula is K plus 1 whole thing squared. So if you were to expand this, okay, you will sub k equals to 1, k equals to 2, k equals to 3, k equals to 4, you get this value 54. Okay, if you were to change the index to p, okay, the formula, of course, you have to express in terms of p, okay, but if you were to expand it, you essentially get the same value, okay. So change of variable actually involves more than that, but this forms the foundation for what we are trying to talk about. Okay, so you can see that okay, at each stage of the expansion, we basically use the index okay, values. Okay, hence k equals to okay, sum of k equals to 1 to 4 for k plus 1 holding square is the same as sum of p equals to 1 to 4 for p plus 1 holding square. Okay, this should be quite obvious. Alright, the change of variables actually involve more than that. So appearance of summation can also be transformed without changing the effect. This is what we're talking about. So given these two expressions, okay, on first glance, they look different. Okay, the formula looks different. The initial value and the final value looks different. The lower and upper limit looks different. Okay, but if you were to expand it, okay, you actually get the same answer. Alright, so this is what change of variable actually entails. We change the look of the summation, but we essentially get the same answer. Okay, so how do we do that? Okay, we will talk about it in the next slide. Okay, uh, question given okay will of course will give you the sigma notation. Okay, we'll give you the summation. And then we will tell you, okay, change the variable. So in this case, you notice that the index is expressed in terms of k, okay, formula in terms of k. And we will tell you, okay, change the index to variable p equals to k plus 1. So this is a crucial piece of information which we will need in order to make the transformation. Okay, so in order to transform this, okay, we need to change three things. We need to change the lower limit, the upper limit, and the formula. Okay. So step one, we need to calculate the lower and upper limit of the new summation. How do you do that? Uh, we basically take the original lower limit. So when k equals to 1, this is the original lower limit. And we substitute this into the formula given to us, okay, the relationship given to us, p equals to k plus 1. So when k equals to 1, p will be 1 plus 1. Okay, you substitute 1 in the place of k, so it's become 1 plus 1, so p equals to 2. So p equals to 2 will be my lower limit for the new summation. Okay, and my upper limit k equals to 4. So when k equals to 4, p will be 4 plus 1, which gives you 5. So p equals to 5 is my new upper limit. Okay, next we will use this relationship here between p and k to express k in terms of p. Okay, so since p equals to k plus 1, which is given as part of the question, we basically take the plus 1, move it over to the other side. So you have k equals to p minus 1. Okay, so this is how k is related to p. K equals to p minus 1. Okay, then we use this piece of information, okay, and substitute it into our original formula here. Okay, so replace all the k in the explicit formula with p minus 1. So k plus 1 whole thing square now will be p minus 1 plus 1 whole thing square. Okay, minus 1 plus 1 cancel off each other, so you have p square. That's our new formula. So you have the new lower limit, new upper limit, new formula. Okay, you will be able to express the original summation notation in its new form. So it will be sum of p equals 2 to 5 p squared. That is our new form. Okay, but if you were to expand both of them, you get the same answer. Okay, so we can check summation of p equals to 2 to 5. For p square, you get 2 square, 3 square, 4 square, 5 square, which is 54. This is actually the same answer as if you were to expand the original summation notation. Okay, here's an exercise. K equals to 5 to 8 for k to the power of 5. Okay, so you need to change the index to the variable p equals to k minus 4. Okay, so recall that we need to calculate the new lower limit, new upper limit, and new formula. So lower limit, upper limit, okay, what you need to do is to say when k equals to 5 for lower limit, when k equals to 5, we sub into here, sub 5 into here, you have p equals to 5 minus 4, which gives you 1. Okay, when k equals to 8, p will be 8 minus 4, which gives you 4. So you have the new lower limit, new upper limit. Okay, then we express k in terms of p. So since p is equals to k minus 4, k will be p plus 4. Okay, then we substitute k equals to p plus 4 into our original formula, the explicit formula. Our formula is k to the power of 5. So since k is equals to p plus 4, our new formula will be p plus 4 to the power of 5. This is our new formula. Okay, so original sum, okay, can be expressed as a sum of p equals to 1 to 4 for p plus 4 raised to the power of 5. Okay, once again, you can check as part of your checking process. Okay, during tests, you can expand the left side, expand the right side. You should be able to get the same value.